Good morning. My name is Heidi Winkowski, and welcome to SonoSim's webinar focusing on applying artificial intelligence towards competency assessment to assist ultrasound program leaders. We'll review lessons learned over the last decade of research and a brief overview of the field of AI as it relates to ultrasound psychomotor skill assessment. Our SonoSim educational specialists will examine the pros and cons of various approaches and the technical merits and system requirements of SonoSim's AI approach to ultrasound competency. You'll be able to see a preview of our 2021 launch of the AI Competency Assessment executed within SonoSim Performance Tracker. After the presentation, attendees will be able to access a complimentary trial of SonoSim's courses and mobile app. All attendees will be in listen-only mode and may ask our panelists questions during and after the session in real time through the webinar chat. A recorded version of this webinar will be available after our session. If you're just joining us, welcome. At this point, I'll introduce Dr. Eric Savitsky, Professor of Emergency Medicine and Pediatric Emergency Medicine at the University of California, Los Angeles. As the founder and CEO of SonoSim, Dr. Savitsky is a pioneer in ultrasound education. Welcome, Dr. Savitsky.
Great. Thanks for the introduction, Heidi. I'm very excited to be here talking with you and appreciate your time that you're taking to learn a little bit about how SonoSim is applying artificial intelligence, or AI, towards ultrasound competency assessment. All right, so just a little bit about today's panelists. So I'll be here with you, a little bit about my background. So I've been at UCLA for over 25 years in emergency medicine, pediatric emergency medicine, and was fortunate to work with a lot of talented people and create SonoSim, which our mission is, heavily focused on helping advance medical care and transform medical care by helping ultrasound programs and training programs train large numbers of users and really help the adoption of ultrasound. And in that role, I've served as CEO and founder of SonoSim over the last 7 or 8 years, as we've worked with all of you to advance ultrasound training. Today, joining me is Gabe Natanelli. He is our CTO and oversees a lot of the technical implementations, especially some of the AI advances. Our lead technical engineer, Tio Zosa, will be here, and then our program manager in charge of web services, which how a lot of these advances are being delivered to you and our clients. Jessica Dickley will be here. A little bit about today's agenda. So today we're really focused on, we'll start off by defining the need for ultrasound competency assessment in terms of how did we arrive at the need, how prevalent is it, what are the potential benefits of automating that process. We'll talk a little bit about what defines ultrasound competency. What are the metrics? What are the criteria? How did we arrive to a consensus on parameters used to assess ultrasound competency? We'll get into the validation of the metrics and lessons learned. We've at SonoSim been involved between SonoSim and UCLA research in this area for over a decade, and we'll get into some of the earlier research and review how we arrived at our current metrics and how they've been validated. And then we'll turn it over. I'll turn it over to Tio, Zosa, and Gabe in our AI team. And they'll really talk about artificial intelligence and a focused application of artificial intelligence as it relates to ultrasound competency assessment. So how can AI be used to really improve how we assess ultrasound competency? We'll talk a little bit about the system requirements in terms of what does that AI application need to look like? What are its parameters? How does it need to be structured to provide maximal value for you, ultrasound program leaders, and folks that are very interested in monitoring and assessing how well people can perform ultrasound. And then we'll also turn it over to Jessica Dickley, who will really talk about how does this get integrated? How does an automated solution get integrated into a workflow, which is a critical part of many AI applications. All right, so as we well appreciate, this is a little bit of preaching to the choir, but anyone who's been involved in ultrasound education and training, like all of us, really can appreciate the training requirements and the elements. It's worth restating, things that you need to successfully teach, as well as assess ultrasound competency. You need an ultrasound machine, an instructor, a student, a patient, most critically with pathology, a teaching moment where all of those elements come together You need to be able to repeat and kind of engage in repetition until you achieve mastery. You need the assessment resources. You need some way of monitoring how well people are accomplishing those tasks. And then you need to know when should you provide refresher training and how quickly do skills decay. So this really gets into the heart of how do you define ultrasound competency. So very early in our research, around 2011, 2012, we really started to look and define what are all the individual parameters that are used to assess ultrasound competency. And fortunately, there was a lot of literature. Tolsgaard and Todston did a lot of early work, seminal work in this area. And what we've arrived at is really looking at the OSHAS criteria, which have been validated by Todston et al. In circa 2013, 14, and 15. And it's basically the objective structured assessment of ultrasound skills. So this was a way of looking at, does a student or a learner know an indication for an ultrasound exam? Do they know the knobology in terms of how to actually optimize the machine settings? Can they get an optimized image, gain, depth, other parameters? Can they perform a systematic examination, completely examining the structure of interest? Can they interpret the image? Do they know how to actually document the image? And then most importantly, this is what you care about the most as a clinician, is can you actually take that information and use it in a clinical realm? So the medical decision-making piece of it. So these elements have been validated, and they've been validated using live assessors. So typically this involves a student, a machine, a patient ideally with pathology, and there's someone with a checklist basically, or it's more subjective, and the more subjective it is, it introduces bias. And if you use a checklist, it becomes standardized, but then there's some downsides in terms of really assessing some of the things that maybe are not on the checklist, or something that an observer notices that may influence whether they think someone's competent or not. But we took these criteria, and these are the criteria we looked to automate. So this is a little bit of the core of today's discussion. So a little bit about the ecosystem, those of you that are not familiar with SonoSim. So SonoSim is an ecosystem, and it has basically about 5 fundamental pillars. And all of these pillars work together to achieve and make sure every student or every learner achieves all of those parameters that define ultrasound competency based on the specific ultrasound application. So there's 70 modules, and the modules comprise courses. So there's about 70 plus courses at this point, added on a regular basis over a variety of topics. The courses are delivered through cloud-based delivery, optimized for mobile platform delivery as well, as you can see on the screen. That teaches you the declarative knowledge, being able to kind of describe the ultrasound application and know what it is. The image acquisition and image interpretation piece is provided through the Sonos simulator, which you see on the screen. So a SonoSim Pro plugs into a laptop, and you're able to scan real cases using the exact hand movements from a fanning, rocking perspective as you go through a volume. The image windows are fixed, so we let you select the image window. We assume people will learn how to get the correct image window with real-time practice, as well as from the course knowledge itself. That's the image acquisition and image interpretation piece. And then we have SonoSim Performance Tracker. So this is very critical to ultrasound competency assessment, and this is where the AI-based product and application we're discussing today sits. From a workflow solution, it sits within SonoSim Performance Tracker. Performance Tracker is basically it's a visual analytic tool that lets you manage your learners, and it has a whole host, an array of different features, which we'll discuss with respect to how relevant it is to ultrasound competency. We have SonoSim Live Scan with Case Builder, which is a technology that really allows you to create medical scenarios using mannequins or real people, and that actually really tests how well can people apply their knowledge to medical decision making. And then ultrasound guided procedure training, which is such a critical piece of ultrasound and patient safety at this point. A variety, if not a majority of procedures now need to be done under ultrasound guidance if you want to maximize patient safety. And that's assuming that you've got the ultrasound training skill to be able to leverage ultrasound to improve patient care. All right, so getting into the specifics of, we talked a little bit about the Todston and Tolsgaard earlier criteria for defining ultrasound competency. We talked about how that traditionally was done with someone looking over the shoulder or observing a learner, either performing an ultrasound task or procedure. And we talked a little bit about the challenges of using a checklist or a subjective sense of, is this person competent? Have they mastered a particular task or application? What we're talking about, and what we'll talk about today, is review the psychometrics research over the last decade that SonoSim has been involved in that leads us to this step. We talked a little bit about how AI can be harnessed for this particular application. How can we improve ultrasound competency through a narrow, focused use of AI? And then the goal, obviously, is to assist ultrasound program directors. Simply, the way we arrived at this moment was one of the things that we did very early on. We validated the Sonos simulator as a way of teaching medical students as effectively as instructors. Back in 2011, our first study, we took an arm of, I believe, 24 medical students in one arm, 25 in another. We had a live instructor versus the Sonos simulator, and we taught the students EFAST. And both groups were equivalent. The Sonos simulator group was actually more effective at diagnostic image interpretation than the live instructor group, but both groups were competent. So there we validated our platform as a method to teach ultrasound. And once the product got out there, at this point, there's about 60,000 users, about 1,300 institutions around the world. We immediately started to get feedback, and the feedback was great. You've crowdsourced learning. You're helping us, meaning we're helping institutions reach thousands of learners. But all of a sudden now, how do we have the resources to assess how well they're learning? So that quickly became a rate limiter. Also, it became very clear that ultrasound program directors, like all of you, institutions, time and resources. You don't have the time and you don't necessarily have the resources at your institution to really assess competency and to standardize your educational format. So could we create a tool that would help you use your time more effectively and more efficiently? Can you hopefully know which students need attention and what type of attention, and ensure that basically everybody achieves a certain level of competency? So that's a little bit about how we arrived at the need, and the need basically has been informed by you and the greater ultrasound community that we've been able to interact with over the last decade. And then we'll get into a little bit of the system requirements in terms of how does the system work, what are its sensitivities, and we'll go from there. So, this was a study we did, and the premise here was psychomotor skills, nature versus nurture. So we recruited, a series of expert sonographers, people that have been doing ultrasound for years, and novices, students who've never seen ultrasound. We took a bunch of very basic shapes that didn't really require knowledge of ultrasound, so spheres and boxes and straws, and used basically our Sonos simulator to see how well can those groups actually execute certain tasks. And we really looked at psychomotor skill, the hand-eye coordination, the visuospatial, visuomotor skill. We validated it using a standard written test for internal validity. And then what we found was really shocking. We thought the ultrasound technicians that have been doing ultrasound 30 years would just do so much better than the novice learners who've never seen ultrasound or have had very little exposure. And it turned out, unfortunately, the older that you got, the older study participants actually had inferior psychomotor skills. So psychomotor skills decayed, and actually our most experienced sonographers actually perform the worst on the psychomotor skills. The other finding that we found relevant was that your psychomotor skills, there's intrinsic traits and there's skills, and some people have intrinsic traits that allow them to have superior psychomotor skill performance, and that was tied very tightly and coupled to age. And people can be very good at what they do because their skills can be developed and trained, and that was the case with some of our more senior sonographers. We were really concerned about the validity of the study, and then we looked at the broader research of psychomotor skills and aging, and we found in every other domain, independent of medicine, whatever domain you looked at, there was really tight coupling of psychomotor skill degradation with age. So that was an eye-opener and was our first foray into the space. Where we went next was we really looked at what can we do to validate the metrics that would be used to assess ultrasound competency? Can we do that in an automated way? And can we validate our platform? Meaning, can we use the SonoSim platform to assess declarative knowledge, didactic knowledge, procedural competency, and can that be done in an automated way? Here we took a relatively large series of participants. We took 86 participants in the study. And we took two procedures. We took one procedure that required didactic declarative knowledge, but not as much psychomotor skill, and that's fetal biometry. So you need your background knowledge, but getting head circumference or BPD or femur length or abdominal circumference, technically it's not as challenging. So we took that, and then we also took another procedure that requires didactic knowledge, but requires fine motor skill, both probe as well as needle. And this was ultrasound guided internal jugular vein cannulation. We took the two arms and then we looked to validate the platform. We looked to validate the metrics and tried to see which metrics actually correlate with ultrasound competency. And then we looked at skill decay at 0, 2, 6, and 12 weeks and tried to see how long do new learners retain their knowledge before it degrades. And we had some fascinating findings which we didn't expect. And this was a really important study for us to do because there was a study that was published by Stunt et al. And it was 94% of simulators that were released across different domains had no validation at all. So, only 6% of simulators that were released actually had validated metrics. So the things that they were testing actually correlated with mastery of whatever the skill is. And then there's some simulators that literally had 40 or 50 different metrics, none of which really correlated with being able to execute the final task, or a small subset of those did. So we felt like this needed to be done. This study needed to be done first before we were able to leverage AI. What we found here was fascinating. We looked a lot at 20 plus parameters that looked at hand motion analysis. At the time, there was a lot of literature being published about hand motion analysis, path length, a lot of other different elements that really looked at motion sensing movement and seeing, does that correlate with being able to predict, can someone be a novice or an expert based on mastery of a task? It turns out for fetal biometry as well as ultrasound guided internal jugular vein cannulation, here we track 6 degrees of freedom, sliding the SonoSim probe as well as rotating, and having the needle executing the procedure. The only things that statistically significantly correlated with mastery was being able to get the fetal biometry measurement as well as ultimately cannulate the internal jugular vein. All of the other hand motion criteria didn't necessarily correlate. So basically, executing the task was the metric that was validated, and our platform was validated as a way of being able to track and see how our users are doing. The other interesting finding was skill decay. We actually found no statistically significant skill decay up to 12 weeks. Historically, 3 to 6 months is where you start to get cognitive task skill decay, and a little bit after that, you actually get the psychomotor degradation. So we didn't measure out to 6 months, and it was difficult because we were using medical students. So a little bit of maybe a testing effect where they get re-exposed and kind of retrained. And then also when you're in medical school, you get knowledge, and it's really hard to sequester someone away from any ultrasound knowledge teaching. So there could have been some conflating bias there that might have led to that. But at the end of the day, what we got out of this, we were able to tightly define the metrics that we wanted to apply AI to assess ultrasound competency, and then we were able to validate our SonoSim platform as a platform that can assess that. Last slide before I transition over to my colleagues is, the importance. We did ontology mapping in about 2014, 2015. So the ontology mapping was, here are all the knowledge nodes and declarative knowledge, and here's all the psychomotor skill and procedural knowledge nodes. And then we used a Bayesian network. We used weighting of that Bayesian network, and we're really able to identify and correlate and validate using a Bayes network ontology mapping format for assessing ultrasound competency. Why this is really important to today's learners. So today's learners, our experience with today's learners is high frequency, small dose, very, very small tidbits of information, straight to the point, but very, very small parcels or morsels of knowledge. The sitting through a 1 hour lecture or 4 hour course is like root canal for a lot of today's learners. So when you're giving high frequency, small doses of information, and let's say every little bit of information is one of these nodes, you have to be able to track that a learner is getting all of the nodes they need to ultimately develop ultrasound competency. So that was something that we built into our platform, and that's something that is built into our competency assessment tool. Is we're making sure that we track didactic, declarative knowledge, as well as the procedural knowledge, even though you potentially are getting those bits of information through various sources. And once again, today's learners are getting it through a myriad of sources, high frequency, low dose. So needing a ontology map that maps all of that makes sure that it translates into competency. And then adaptive learning platforms in the future will be able to customize that education to how well someone is progressing, which becomes critically important for competency-based education and learning, which is where graduate medical education and undergraduate medical education is headed. So I'm going to transition from this slide to my colleague Tia Zosa, who's going to talk about artificial intelligence and AI. Thanks for your attention.
Great. Thanks for the intro, Dr. Savitsky. So as you mentioned, I'm Tio. I'm SonoSim's resident AI research engineer and technical lead. And so what I want to do first was I wanted to give our audience a high-level background overview of AI as it relates to the work that we're currently doing at SonoSim. So first off, what is AI exactly? In truth, AI is actually a very broad field. Though we often equate modern AI with computers and computer science and algorithms, it actually spans many other disciplines as well. Some of these include mathematics, psychology, linguistics, philosophy, cognitive science, and even neuroscience. And that's just to name a few. So for historical reasons, it actually has many definitions depending on who you ask. However, one that I think actually serves us well in the context of our discussion is this one, which is a system's ability to automatically adapt its output to specified inputs in order to accomplish a predetermined goal or task. So maybe another way of putting it is this. It's an automated task-specific decision-making system that does the right thing given what it knows. And in the field of AI, we often use the term model to describe these types of systems. And so next up, we have machine learning, which is actually a subfield of AI that extends the previous definition to a model that does all of the above, but which automatically improves with experience. This latter point is actually fairly significant because experience often means data, and this data is needed in fairly large quantities, which in the medical setting isn't always readily available due to privacy considerations. And additionally, even when you do have access to enough data, many machine learning models require domain experts to transform this raw data into domain-specific input. This is actually a very time-consuming process that we call feature engineering. And then lastly, automated improvement is achieved via an automated training regimen. So for instance, supervised learning in particular is the most commonly employed training regimen. However, it requires a target output data set in addition to an input data set. So this often means costly manual annotation of data, which adds further complexity to the application of this type of machine learning. And then to make matters worse, in the context of medical tasks, this annotation process has to be performed by medical SMEs. And finally, we have deep learning. Deep learning is a class of machine learning that's characterized by its usage of the eponymous deep neural network. And deep neural networks are a class of machine learning model that have architectures that have been inspired by biological neural networks, hence the name. And the great thing about deep neural networks is that in contrast to machine learning models, classic machine learning models that is, deep neural networks actually can obviate the need for the costly feature engineering that I mentioned in the previous section. And they do so actually by exploiting the raw statistical properties of the input domain, automatically identifying and then encoding high-level relationships and concepts directly from the raw data they've been fed. So the great thing is not only does this make machine learning in general more feasible, deep neural networks have actually frequently produced results that meet or exceed human level performance across a huge swath of tasks. And this includes some that were previously considered, extremely difficult, if not even impossible. It's pretty amazing stuff. And even anecdotally, internally, we've had major success applying deep learning to a variety of problems within the purview of AI R&D. So for instance, some of these include volumetric image enhancement, where we used self-supervised deep residual super resolution neural networks, video frame interpolation, where we used the depth-aware interpolation network, language localization, which we were tackled using speech-to-text models for automatic speech recognition, in addition to text-to-speech networks for neural machine translation. And then finally, full text semantic search, where we actually used transformer-based language representation models that had been trained on biomedical data. And that's just to name a few of our more interesting R&D AI applications that we worked on at SonoSim. So even with all that being said, while we see that deep neural networks have shown great performance, they're actually not without caveat. For instance, some of these models still require lots of data from which to learn. So consequently, data curation and then, often annotation is still a very significant requirement. And additionally, maybe even more importantly, a major criticism of neural networks is that we have no reliable way of determining why a particular decision was made. And we actually call this a lack of explainability. Also sometimes refer to it as the black box phenomena, and that's because it stands in contrast to what we call white box or explainable AI algorithms. So with all that out of the way, how is SonoSim applying AI to competency assessment in particular? And maybe the better question is, why use AI at all? So from the outset, our goal was to create a best-in-class decision support system for competency assessment. And in our minds, best-in-class meant our system had to be on par with instructors, our literal best-in-class users. And so to do this, we knew we needed a system that could emulate experts with a very high degree of fidelity, and something which could ultimately, in our minds, only be achieved by an AI system. So consequently, as a first step towards this goal, we wanted to employ a class of interpretable models known as expert systems. These are transparent white box AI algorithms that actually provide a robust, rigorously validated way of directly encoding expert knowledge, and doing so in a way that actually accurately mirrors the problem space, in addition to providing the means to automatically act on this knowledge. So specifically, we wanted to apply it to the task of optimal window tagging of learner-acquired images from our Sonos simulator. And this is due to the fact that based on conversations with customers, we identified this assessment subtask as one that would provide the most immediate value to our customers. Our expert systems directly integrate SME knowledge by design. In so doing, our expert systems actually provide explainable decisions that have been validated by empirical research in addition to our resident SMEs, doing so, importantly, without the need for any private user data, and in a way that's fully interoperable with learners' workflows. So ultimately, at a high level, this allows our system to provide instructors with rapid and immediate access to a broad library of ultrasound content, which they can use to assess ultrasound competency, seamlessly integrate into learner workflows across a wide clinical breadth of ultrasound competencies, and finally, deliver highly accurate, explainable, and empirically validated assessment support decisions. So to finally dive into what that currently looks like in the product, I wanted to hand it over to our product manager, Jessica Dickley. She's going to take her time to introduce our AI-powered automated assessment in the context specifically of our SonoSim Performance Tracker.
Hi, everyone. My name is Jessica, and like Tio said, I'm your product manager here at SonoSim. I'm going to go over the tools that SonoSim currently uses to assess ultrasound competency, as well as talk about our upcoming AI innovations that we'll be releasing in the future. Within SonoSim, we currently have tools to assess both declarative and procedural knowledge. Our first ultrasound competency assessment tool is within our SonoSim courses, where we automatically assess learners' declarative knowledge via our in-course assessment questions and our mastery test. As students move through each lesson of the course, they are frequently presented with assessment questions that check their knowledge retention of the current lesson. And after answering those questions, the students are provided with immediate feedback, as well as an explanation of why their answers were correct or incorrect. And after a learner has finished the whole course, they are asked to take a 20-question mastery test, which is graded immediately after submission. If a user passes, they're able to go back and review and see feedback on what they got wrong. Additionally, SonoSim has ultrasound competency assessment tools that evaluate procedural knowledge as well. SonoSim has a whole category of modules devoted to ultrasound guided procedures, including vascular access modules, synthesis modules, and joint injection and aspiration modules. And in all of these modules, after learners gain the required declarative knowledge in the SonoSim courses, they are then instructed to put that knowledge into practice via our SonoSim scanning cases. In our procedures modules, after learners complete a survey scan, they then perform an ultrasound guided procedure by using the keypad to advance the needle towards a target structure. Our SonoSim AI is able to assess whether the procedure was successful or not, and if not, can provide feedback on what exactly went wrong. So for example, the SonoSim AI can provide feedback on whether the learner didn't advance the needle far enough, or perhaps they advanced it too far and hit the back wall, or perhaps they hit an artery. All of these use cases wouldn't be ideal in performing a real procedure, so the SonoSim AI will alert the learner to these mistakes in practice so that they can be avoided in the future. One of our more recent innovations is the SonoSim module assignments. These assignments are guided instructions for learners that turn the most critical aspects of SonoSim courses into hands-on tasks within the SonoSim scanning cases, testing whether the learner has the required psychomotor skills to execute the task. So for example, if the learner has just finished the EFAS course and wants to put that knowledge into practice, the corresponding SonoSim module assignment would then tell the learner to go to that first EFAS scanning case in the RUQ window and look for free fluid in the Morrison's pouch. The learner would then be instructed to capture an image of Morrison's pouch and write in the annotation whether the free fluid was present or not. That image and annotation would then be available to their instructor within SonoSim Performance Tracker for review and feedback. So the SonoSim module assignments are really a great tool for learners to get the full potential out of SonoSim, but we recognize that previously they have been time-consuming to grade, especially for our larger programs. Our upcoming AI automated assessment tool, which is slated to be released this summer, seeks to remedy that. So let me walk you through our new automated assessment feature. Automated assessment will be an add-on to our existing image feedback feature within Performance Tracker. To use automated assessment, select your learner and module of interest. All images taken by that learner from that module will appear on the screen. And when you're ready, you can turn on the automated assessment feature. So you'll notice that all images are now populated with an overall grade automatically. You can use the expand grading options feature up here to automatically show all subgrades. Automated assessment will provide a grade of acceptable, suboptimal, or unacceptable as indicated by the legend at the top. Any subgrade that was graded by automated assessment will have a SonoSim symbol next to the grade, indicating to the instructor and the learner the grade was provided by the SonoSim AI. If the instructor would like to compare the student image against SonoSim's optimal image, simply click on the student image. This will show a side-by-side comparing the learner image and the optimal image. And lastly, if the instructor disagrees with the automated assessment grade, they are able to change it to a grade of their choosing. Changing the grade will update the symbol from the SonoSim icon to an instructor icon, letting the learner know that the grade was chosen by the instructor. With automated assessment, a learner's images will be automatically graded based on image orientation and scan plane. Our SonoSim AI will be able to provide each image with a score of acceptable, suboptimal, or unacceptable. Once graded, an instructor can use the filters over here on the sidebar to filter down to only the non-optimal grades, and from there provide more in-depth feedback via the text box, saving the instructor's time overall while still allowing them to provide personalized feedback to the learners who perhaps are struggling with a particular concept. In the first iteration, automated assessment will be able to automatically grade scan plane and will eventually expand to grade depth and gain as well. Looking more long-term, SonoSim would like to expand automated assessment beyond just grading image acquisition and create solutions that assess image interpretation and integration of ultrasound findings into medical decision-making. So, I hope that was helpful in explaining what AI SonoSim is currently employing, what we're planning on doing in the near future, and what our longer-term goals are. If you have any questions, please write them in the chat now, and we'll be able to answer them during our Q&A session.